And what's its minimum? Yes. Okay, so how could we use that to sketch part B? If it's in a bracket next to the x, it affects the x direction. Yes. And so what's the root for it now? 2, 0. And part C. Yes. And so that's going to be something like that. What's its y-intercept? So it's going to be 0, 2. Well done. So if it is in a bracket next to the x, it affects the x. If it's not in a bracket next to the x, it affects the y. X is the opposite, y is the same because it's been brought across. Yeah, you would just sketch the first graph and then transform it. How would we do, what's going to happen? Yeah, how would we do this one? Do you remember what the y equals 1 over x looks like? Yeah. So the asymptotes of the original are x equals 0 and y equals 0, because those are the lines that they get close to but never touch. What will happen to this? How will that change it? Yes, so that's going to move up by 1. And so what is your new asymptotes? If it moved up by 1, that affects the y. And so it would be y equals 1. X equals 0. So if this one goes through the... Yeah, because it goes through... Yeah, people always mix those ones up. Yep, okay. That's all right. That's going to be okay. Let me see this one. Write an equation of the curve. That's all right. What would you do for part B? Nope. Yep. -2. Nope. What would this be? At the moment, it's 0 minus 32. Yeah, and so clearly showing the coordinates of the point where it intersects. No, I'll just do it like that. This part here is now 2 minus 32, but that doesn't intersect. I don't think we can know what this is. So I think there's -2 and 4, and it doesn't hurt to show that as well. Oh, yes. So yes, sorry. So you'd have to do part A to do part B. That's it. Sorry, I didn't realize we were given the equation. Yeah. Grand. But I just don't want to spend a lot of time on that stuff. That's not really that's more sketching graphs. That's not really transforming graphs. This one, how do we do part B? And I'll just do a little summary to help, like from A. So the Brilliant. So that time they gave you the transformation, they gave you the graph, and you had to say how it was transformed. That's okay. You know, no, that's okay. I think it's easy stuff. This one, yes. How about this one? Yep. It says values. What's that about? Yep. How else could you get this graph to go through the origin? A is in the bracket next to the X, so it can only shift left or right. It works the opposite way, so it's -3. Yeah, essentially that would have to be -3. X would have to be -3 to make this 0, or 2 to make this 0. 2 or -3. Yeah, 2 and -3, because it works the opposite way. Any questions about that? Everything okay there? Okay. Let me just take a look at this. Blah blah, easy. Where is distinctions? Okay, this is real tricky. Do I bother with this one? I'm not going to bother with that. It's not really similar to every other question. Let me see this one. All right. How do we do this one? I don't believe you need the first part. Is a constant. I'm happy with that way of going about it. Yeah, and it's either 1 or -1. But you're right. You'll get x squared equals 1, and so you get plus or -1. That method will work. And that one's very similar. I'm happy with that method. Okay, translating graphs. Right, stretch time. Okay, how do we do example 12? Yeah. And so what would you how would you show that? So at the moment it looks like that. -3, 3, 9. After it's transformed, what would it look like? So you said it's compressed. What will happen to these three coordinates? Nope. Nope. You were right the first time. Yes. What's the how about this y-intercept? Correct. How about part B? Well done. So that's 1.5 minus 1.59. And then we have part B, which goes there and there, but up to 18. So let me try this. There we go. That's 18. That one's B. And red is A. That one minus 1.5 to 1.59, and then 18, 3 minus 3. Grand. Sketch this curve. How would we go about doing part B? Mm-hmm. Okay. What's that gonna do? Yeah. And so let's say what will happen to this point? Correct. Correct. And so it'll be it still goes through the same points on the X. Yes. So a stretch by -1 is a very special type of stretch. It's a reflection. And that's what we get. Yes. Any questions there? Stretch is effective reflecting the curve. Yeah. Okay. Let's see. What would be the first one? Yeah, I don't, I think, oh, sorry, there it is. F of x is that one. Okay, yeah, so it's a reflection in the y-axis. And the other one? Yeah, and so that's it. And so, so the second one is gonna turn into a negative quadratic like that. But a reflection in the y-axis is gonna look like that, I think, is it? So this was at -2, so now that's going to be at +2. Yeah. That's it. Okay, you're doing well. Okay, let's see what these have for us. All right. What's going to happen to these coordinates? Nope. Sorry, A. A minus 4 0. Yep. I was looking up 8. Yeah. Yep. Great. I'm happy there. 0 2 2 0. Grand. What is part B? And so what will be the new coordinates? Yep. Minus 2 6. Let's see this one. Okay, what's going to happen here? Part A, or let's say part B. What is the equation of the new curve? Plus 5 squared x minus 1. And what would happen to the coordinates? And so what are the new coordinates for A, B, and C? Yeah. Yep. Yep. I believe so. 0 minus 75. That is, what would be part A? Nope. Yes. Yeah. That's the first time that happened to you. And so I'm pretty okay with that. Let me see. Oh, this is interesting. Okay, so they give us the new coordinate, and we have to say the value of A. And B. Looks good to me. A is 8. And I don't have B. Okay. Easy. I suppose. Alright. How about this one? Yep. Well done. You redeemed yourself. Let's see. Is this worth looking at? Passes through 1 0. Would it involve sketching it perhaps, would it? Oh no, not really. Alright, let's give this a go. We can just do part B if you like, if you can get away with it. I'll sketch A. Something like that. A is what, sorry? Is equal to 3. Pass through the 0.10. That's A. Do I have the answer for B? I don't. Why did I do that? Let's see. The graph of that one. So A would be 2 or A would be 3. Yep. Okay, stretching graphs. Nothing wrong with that. So what will happen to the graph for part A? Okay, so let's just use the point A for everything. What would the point A be? Yeah. How about B? C. D. Yep. And E. Yep. So that was 1, 2. And that was 1, 5. Those are really the only two worth checking. 1, 2, and 1, 5. And you could mess around with the other point as well. But yes, if you're stuck, you can just bring them across to the other side. If it's next to the Y, it's same as like if it's next to the X. It's the opposite. You did great. Let me see. That's straightforward enough. So the reason why they use a function of X is so they don't give you the equation of the function. So you can't put it in your calculator. And so it thwarts that. Let's do. That's a good point. Yeah, you could find the equation of the function. Yeah, if we go back, this one, yeah, you could totally. Yeah, this one is squared. X plus 1 is squared. Yeah, so that's not even. Okay, let's do B3. Smarty pants. Nope. How did you get 2? Oh, sorry, the point. Oh, sorry, I was looking at Q. So we're looking at point P. Yes, 2 and so what would be how did you get minus 4.5? And And so what would the y coordinate be after that? Okay. Yes, that's fine. Yeah, and I was just checking that you're using BidMess. Do the multiplying first, adding and subtracting last. Okay, so it's just subtracting as always is the tricky thing. Let's see. That's fine. And then where a is greater than 0, should allocate any points. Is part B worth doing? Has a minimum at 4 minus 16. Oh, on each diagram, I thought that was part of it. Show the locations, any points where the curve intersects the x-axis, and of any local minimum or local maximum. Sorry, this is what I was thinking. I don't think so. So what is x minus a in general? And so what would 4 minus 16 become if it was translated a units to the right? Yes. So that'll be 4 plus a. So it'll be something like, so long as you sketch something like that, where the minimum is 4 plus a and minus 16. And how about the 8? I believe so. 8 plus a, 0. Hang on. So you would have another one that's a. So this one is a. This one is 8 plus a. And then this one is 4 plus a minus 16, I believe. Yeah, that's what they were looking for. A plus. Yeah. And so, okay, so we're getting into algebra. You and your algebra. Okay, let's see this one. Yeah, let's do this one. So, seems wrong. So what does the 2 changes that to minus 1, and this minus does what? Yeah, that affects on the x. And so how about the point B? Think about it. Yeah. 1.516. There we go. Okay. Good. Any questions there? They're giving you these things. This 6 marker looks like it might be. Nope. On each. Oh no. So that's just those 2 separately. So just sketch that. That's fine. There's a local point at that. It's fine. So we did that stuff already. Asymptotes are always good to do. Let's do an asymptote one. Oh, this is a nasty one. You don't know. Ah, you're so smart. Yep, Mrs. Smarty Pants with her algebra. No algebra here. Just the f of x. There was one similar that I skipped over earlier. Do I bother? All right, I better go back and do that. So it was for translating. Yeah, all right. Try this one. It's very similar. So this has one root at p. What would we have to do to make it have 3 roots? By how many? Mm-hmm. Could they be 1? Sorry, minus 1 if you moved 1 down? Mm-hmm. Okay, so if q moved minus 2, so it moved 2 down, would it? It would it? So what's its coordinate then if it moves 2 down? And if it moves 2 down? If q moves 2 down? 1, 1. Oh, sorry. Okay, so basically, like, would 3.5 work? Yes. Could it be or equal to minus 3? Why not? It would be. You'd have 2 roots. They wanted 3. It would just touch if it went exactly 3. Yep. Yeah, definitely it's a root. And so is it or equal to or not? Correct. What if it moved 10 down? Bingo. And so if that moved 10 down, then it goes back to having one root there. Okay, but minus... okay, it moves 9 down. Okay, it moves 7, minus 8. It moves 7.5 down. So what would the coordinate of this be if it moved 7.5 down? So that would be minus 0.5. Well done. Yes. If it was or equal to, that would be the same thing. You'd get two roots. Well done. Very, very tricky. In between minus... Yep. That's why I skipped it. It's like, those are the kind of marks you want to lose. Let's see. Where was our thing? Yep. Can we use that to do C? I don't know if we can. No, at the value of K, that's easy. That's just minus 11, is it? No, that's easy. Minus 11. That was an easy one. This was the one, the asymptote one. This is what we were talking about. So try it now. Solution is another word for root. Okay, so find the range of possible values. Oh, you're gonna make me do this again, aren't you? Okay. It moves 3 down. Can A be minus 3? So okay, how it would if it moved 3 down, so I think you mean less than minus 7, like minus 8, minus 9, minus 10, that type of thing. Oh, sorry, we need to keep at least one root. So we have to keep at least one root. Let's see. So we're going to have one root between here and here. If it moves 3 down, you'd get 2 real roots, I think. So I believe if A was between, so I believe if A is between 0 and -2, so if it moves 2 down, technically that's going to asymptote, so it still won't have a root, but it'll still have this root, so that'll work. If it keeps going down, I believe then it would have no real roots. If you went down by -7, it'd be like that, wouldn't it? If it went down by, let's say, 6, so I think that's a special case. A is exactly -6. But I think there's no other possibility, is there? Like if it went down by -5 or something, then you'd have 2 real roots. It'd be something like that. So I think that this is what they were looking for, between 0 and -2. But I think what's the cheat for set notation again? What is it? Y? Yeah, Y such that, and then just curly brackets around the thing. No. Those would be the integer values, like 0, -1, -2. But yeah, it's a real number, and so it's not an integer. Okay. Yes, I think we might have to do. I think this. Yeah, A. I think that because A could be A equals -6, and I think it would be the union of those two. Let us see. No. But I don't like this answer. A is greater than or equal to -2. I said it was between 0 and -2, but actually, yes. If you went up forever, you would still have this root. So that will work. A is greater than or equal to -2. And so this should be in the bracket. I wrote Y. So you don't need A equals for there. A such that A is greater than or equal to. So just A such that in curly brackets. Sorry? So that's set notation. So just your normal answer, and then you just do, it's usually X such that. You just do A such that and curly brackets around it. This was very tricky because you had union -6 as a special case. Yeah, so those two, you can see why I skipped them. I'm like, you know what? Like, that's just not. Me neither. That makes two of us. Okay, so we're not sketching graphs. Let us see. We skipped over all these, but we did all of them. So there's basically 3 types, I think. There is, oops, I passed. There's translations. There is stretches, kind of, yeah, like reflections as well. And then there's all of them, but without the ability to find the function, and so that kind of forces you to do it by transformation as opposed to by calculator. If you were really stuck, you could do it by calculator. I wouldn't recommend it. Just try doing it. You could use a calculator to check your answer, I suppose. Oh, you did great. You only made that mistake once, and we did every possibility. So yeah, 2 to the right, 2 up. If it's in a bracket next to the x direction, if it isn't, y direction. So they all have that kind of opposite effect, but basically the x direction is the y-axis, so the x direction will still work. So if x becomes minus x, then it's still, all the x's will change their sign, so it'll be in the x direction. Yeah, so they all have that opposite effect to them, but x direction just refers to, so you can imagine if you have a reflection in the y-axis, that is the x direction. And so yeah, you're pretty good with the x's. I'd just stick with that. Yes, and so true for everything: translation, stretch, reflection, everything. If it's in the bracket next to the x coordinates are changing. If not in a bracket next to the x, it's the y coordinates. If it's on the left side, right side, anything. Let us see. So reciprocal graphs, yes, asymptotes. If it moves 1 up, that affected the y. So the y asymptote was you add 1 to it. And even those lines are the opposite with each other, but I just go with that method of remembering it. That was 2 to the right. That was fine. That was fine. Yes, so it can. These ones seem to be quite common. It can either move left 2 or right 3, and so those are the 2 ways of doing it. That was easy. So this was the hardest to type. The range of values is between -3 and -7. Let's just forget those ones. Rest were good. So stretch, yes, x direction affects the x coordinates, y direction affects y coordinates. Special type of stretch is by -1, which is a reflection. Those were fine. Yeah, so it's a reciprocal. Other than that, it's fine. That was fine. That was fine. I think this one was also fine. This one you got, it was good, working in reverse. Then we had functions. Yes, if it's not y equals, you can just make y the subject. Yeah, but yeah, if it's next to the y, it's the same thing as the opposite. It's next to the y, so it's +1. Yeah. Here you had 2 transformations. Just make sure you use BIDMAS, multiplying and dividing before adding and subtracting. Algebraically, so if it was x minus a, add a to all the x coordinates. 4 plus a, 8 plus a. Yeah. And I suppose the only reason why they said a is greater than 0 is so that we wouldn't move it to the left, because then you'd get minus minus, so it'd be plus, and so it would go to the left. They wanted to show that you'd know it would go to the right. So this probably not even worth mentioning, but this has two transformations, one in the X direction, one in the Y direction, and so it doesn't matter what order you do them in. But I'd still follow BIDMAS. That was fine. Then we had this real tricky one. Set notation, just curly brackets around everything, and A such that before it, or usually X such that before it, and just curly brackets around it. And then we had union or -6, and that was transforming functions. So that's transforming functions. I don't think there's sketching graphs. Do you know your reciprocal graphs? Okay, so yeah, you always have your calculator, I suppose. 1/x². So it's the important, yeah. That's what it looks like. Any idea what's going to happen in this one? Yeah. And any idea what, if there was a number on top, like 2, 3, 5, 11? Yes. So although the asymptotes are the same, so they'll eventually reach each other, it'll just be further away from the origin. So not necessarily further away from the axes, but further away from the origin. So eventually, so I mean, you could draw it like that, and that's fine. Like sketch it like that. But just for your own sake, you know, it goes eventually there. Yeah. So if you had to sketch two things, like 1/x and 3/x, you would show that that one is 3/x because it's further away, and then the other one is 1/x, and that would show that that's what they tend to look for. Yeah, how was that for you, Amogha? Any topic in particular you want to do? Sorry? Great. I hate projectiles. But I've gotten better at them. Oh, really? All right. Oh, okay. Any questions for me in general? All right. Well done, Amogha. You did great. That's all right. And good luck with your project, I think it was your mum was saying. Your presentation. Well, yeah, have a good one, Amogha, and see you next week. All right, goodbye.